Hi, my name is Elke Zimmer and I'm doing my postdoc in the STAR project. I want to tell you today what is DEBtox and why are we using it. As you know, in ecological risk assessment we need mathematical models. So what we're doing is we do experiments in the laboratory, as you can see here, for example, as with snails in the beaker. We stress them with different types of stressors, and then we are trying to understand what is actually happening in the environment in a little pond like this. And we need some way of extrapolating between those two situations. And we also need to understand not only what happens to one of the snails, but what happens in the population of snails, and thus in the population of snails in the environment. And what we normally look at in the laboratory is, for example, a 50% effect on the reproduction of the snails. So as you would see here, this is the normal reproduction. There's one snail making 6 offspring. What would be if there's an effect on reproduction? Instead of 6 offspring, the snail just makes 3. It could also be that if we see a 50% effect on reproduction, that instead of influencing the effect actually on reproduction, the offspring is killed. But we don't see it because we just see an effect on reproduction. The same it could be that there's an effect on the snail itself, which results in an effect on reproduction, but the effect is actually on the snail itself. Or it could be that the snail is affected by the food uptake, which doesn't have to do directly with reproduction, but the effect that we see is on reproduction. It could also be that we don't see an effect on reproduction rate at all, but we just have smaller offspring, which we don't see if we just measure reproduction rate. So this is why we use dynamic energy budget theory. We are looking at the whole energy budget of the organisms. We look at how much energy goes in via feeding, how much energy is then used for maintenance, just pure survival, how much energy is then left over for growth, and then for reproduction. So if there's an effect on one of those processes, we can follow all the effects on the different endpoints simultaneously. So we can have a look at an effect on feeding, or on maintenance, or on growth, or on reproduction. And each of these processes matters on population level, because if the snails are affected in feeding, if they eat less, there will be more food for the other snails in the environment. And all these other fluxes, when they're influenced, have a different effect on population level. This is why we use DEBtox for more informative and integrated risk assessment. Thank you.